Have you ever wondered what would occur if lava were poured over a glass surface? Would the glass succumb to the intense heat? Similarly, placing a hammer beneath a hydraulic press machine, could the mighty hammer be broken? And imagine submerging the latest iPhone in liquid hydrogen. What would become of the cutting-edge device? In this video, we're set to explore amazing science experiments that promise to deliver unforgettable experiences. However, before we dive in, make sure to subscribe to our channel, Saftium, for more such exhilarating content in the days ahead. Number 1. If you were to combine a substantial quantity of Coca-Cola with a multitude of Mentos candies in a science experiment, you would trigger a dramatic and explosive reaction. This iconic experiment is renowned for its visually captivating display and has been widely explored for its scientific principles. When the Mentos candies are dropped into the Coca-Cola, a chemical reaction occurs that rapidly releases carbon dioxide gas. The surface of Mentos candies is covered in countless tiny pores, providing an abundance of nucleation sites for gas bubbles to form. Additionally, Coca-Cola contains dissolved carbon dioxide gas due to its carbonation process. As the Mentos candies come into contact with the Coca-Cola, the pores on their surface facilitate the rapid escape of carbon dioxide molecules from the liquid. This creates a sudden influx of gas bubbles, which rapidly expand and accumulate on the surface of the candies. The intense buildup of gas pressure within the liquid, combined with the growing number of bubbles on the Mentos surface, leads to a highly energetic release. This release is so forceful that it propels the liquid upwards in a frothy and effervescent fountain. The result is a visually striking eruption of Coca-Cola that can shoot several feet into the air, often accompanied by a shower of fizz and foam. Number 2. Submerging a new, working iPhone into liquid hydrogen gas would likely have disastrous consequences for the device due to the extreme cold temperatures and potential chemical reactions. Liquid hydrogen is incredibly cold, with a boiling point of around -252.87 degrees Celsius -423.17 degrees Fahrenheit. Placing any electronic device, such as an iPhone, into such extreme cold temperatures would cause a rapid drop in temperature, which could lead to various problems. Cold-induced damage * the extreme cold could cause the materials in the iPhone, including the plastic, metal, and glass components, to contract and become brittle. This might lead to cracking, shattering, or other structural damage. Number 3. Placing a hammer under a hydraulic press can lead to various outcomes depending on factors like the type of hammer, its size, the force exerted by the press, and the material the hammer is made of. Here's a general overview of what might happen. The hydraulic press can exert an immense amount of force, which might cause the hammer's metal head to deform. The head could become flattened, bent, or reshaped due to the pressure applied by the press. If the force exerted by the hydraulic press is significantly higher than the hammer's structural integrity, the hammer might break or crack under the pressure. This is especially likely if the hammer is made of a relatively brittle material. Number 4. Directly pouring melted hot lava over a glass screen would result in the glass screen experiencing extreme thermal shock and likely shattering almost immediately. The differences in temperature between the molten lava and the glass, as well as the intensity of the heat, would cause the glass to crack or break apart. Extreme temperature difference. Melted hot lava can reach temperatures of over 1000 degrees Celsius (1832 degrees Fahrenheit), while most types of glass used in screens have a much lower melting point. The sudden and intense heat difference would cause the glass to rapidly expand due to thermal stress. The rapid and uneven expansion of the glass due to the extreme heat would create internal stresses within the glass. These stresses would lead to fractures and cracks forming on the glass surface. The combination of thermal stress and internal fractures would likely cause the glass to shatter into multiple pieces. Number 5. If you were to place a football in a shredding machine as part of a science experiment, the outcome would likely be the destruction of the football into smaller pieces. Shredding machines are designed to break down materials into smaller components, and a football would be no exception. When the football is introduced into the shredding machine, its sharp blades or mechanisms would start to tear and cut through the material. The force applied by the shredding machine would break down the football's outer casing, stitching, and internal components. Number 6. Hot metal ball on gallium. Gallium is a metal with a low melting point of about 29.8 degrees Celsius, 85.6 degrees Fahrenheit, which means it's solid at room temperature but can melt easily with a little added heat. If you were to place a hot metal ball, assuming it's hotter than gallium's melting point, onto solid gallium, the gallium would melt upon contact with the heat from the metal ball. Now what if we put blue light on gallium? Gallium itself doesn't have any significant reaction to visible light, including blue light. However, if you're referring to the interaction of blue light with liquid gallium, there would likely be minimal interaction. Number 7. In the microgravity environment of space, water behaves quite differently than it does on Earth due to the absence of gravity. In space, where gravitational forces are significantly weaker, surface tension becomes much more dominant. Water tends to form spherical droplets due to its cohesive properties. These droplets minimize their surface area to conserve energy. This behavior is visible in microgravity environments, where water forms floating spheres. In the absence of gravity, water droplets don't settle to the bottom like they do on Earth. This effect is often seen on the International Space Station, ISS, where astronauts conduct experiments with floating water droplets. We believe that this video is going to be very interesting and informative for you. For more such entertaining videos, must like and subscribe to our channel Saftium. We'll see you in next video.